Okay, so in the last class we discussed about the components of internet. What are the different components of internet, end user, links, as well as the router and switch. I think you got a rough idea about the router and switch. Router and switch, two predominant forwarding device in the network. Okay, so now in this lecture we are going to discuss about the way in which the internet to be accessed. Okay, so we are going to talk about the residential access. Okay, as a residential user, what are the possibilities are available for you to access the internet? Okay, or what are the things are available in the developing country for accessing the internet? Okay, residential internet access. And if you are the person in the institution or organization, you can access the internet not as a residential access, as an institution access. Okay, so for institutional point of view, how to acquire the internet access. Okay, I will tell you that one also. And finally, we have flexible option for accessing the internet mobile network. Okay, we are going to talk about a mobile network, 4G, 5G cellular network. Okay, so we can access the internet in any one of the three forms: residential access, or institutional access, or mobile access. Okay, but whatever may be the access, it would provide a common bandwidth. Bandwidth means speed. Okay, how many bits can be transmitted per unit of time. Okay, in terms of kbps, or in terms of mbps, or in terms of gbps. Okay, 1 kbps is equal to 1024 bits. Okay, 1 mbps is equal to 10 power 3 kbps. Okay, I think that's not a big thing. So you have to worry about the bandwidth of the product, bandwidth of the access network. Okay, all the access networks are not providing the same bandwidth. Okay, and all the applications are not the demand of bandwidth requirement of each and every application is also different. Okay, if you are accessing the http, the bandwidth requirement is different. If you are accessing if you are doing video conferencing application, or if you are executing VoIP application, the bandwidth requirement is different. Okay, so we are going to think about or discuss about the bandwidth availability of each and every access network. Okay, local area network, or residential network, or mobile network. Okay, and in these cases, residential access network and institutional access network, some of the channels are shared channel. Okay, some of the channels are dedicated channel. Okay, we have to think about that also, so that you can understand uh, the way in which the channel is accessed by more than one user at the same time. Shared channel and dedicated channel. So the difference in terms of bandwidth. Okay, all these access networks, we are going to discuss about three different type of access network. That is residential access network, institutional access network, and mobile access network. Okay, all these three networks are for accessing the internet. Okay, so differs in two different perspectives. One is bandwidth, that is the amount of speed, the amount of bits that can be transmitted over the network varies, as well as the channel also varies. Shared channel, some of the channels are shared channel, some of the channels are dedicated channel. Okay, that is what we are going to discuss today. Okay, so first let me get into the residential internet access. Okay, traditional residential internet access. Traditional. Okay, I think 5 years before, in India, most of the homes are having, most of the homes are equipped with landline telephone. Okay, so the landline telephone is actually telecommunication network is a base for the internet. Okay, so AT&T is a top level internet service provider. AT&T is mainly for telecommunication. Okay, so each and every home, developed country or developing country, definitely have the telephone, landline telephone in every home. Okay, so the landline telephone, normally telco network, telecommunication network, telecommunication networks is based on trunk office and toll offices. Okay, so if you take telecommunication, simple telecommunication network, in each and every street. Okay, all the telephone links from each and every house is connected with the street office. Okay, that is known as trunk office, and all the trunks are connected with the toll office. Okay, so that infrastructure already available, that infrastructure already built. Okay, so that infrastructure is for analog communication, telephone communication. Okay, but if you think about telephone communication, it requires very minimal bandwidth. What is the requirement? For transmitting and receiving the audio signal, the maximum requirement or maximum frequency requirement is just 4 kilohertz. 4 kilohertz frequency is enough. Okay, so 4 kilohertz frequency, if you take a 4 kilohertz frequency, we can easily compute bandwidth requirement. I said each and every access network to be evaluated in terms of bandwidth requirement. Okay, see what is the bandwidth requirement for 4 kilohertz analog signal, audio signal? Actually, if you apply Nyquist theorem, because we need 4 kilohertz frequency band. Okay, so in order to reduce the noise, you have to apply the Nyquist theorem. If you apply Nyquist theorem, the required frequency to transmit the analog signal with the 4 kilohertz frequency is 8 kilohertz. Okay, I'm not going to talk more about Nyquist theorem and all those things. For time being, you assume that audio signals requires 8 kilohertz frequency. Okay, to transmit 4 kilohertz data. So if it is 8 kilohertz frequency band, if the requirement is 8 kilohertz, if you are using analog to digital converter 8 kilohertz, I think I said already, I think so, but anyhow this is an important point, because what we are using is existing telephone communication infrastructure. Okay, so telephone communication, whenever you talk about telephone communication, the basic demand of telephone communication is a channel with just 64 kilobits per second bandwidth. Okay, it's enough. But nowadays we have 1 Gbps or 10 Gbps, even terabits per second cables are available. But telecommunication, perfect telecommunication, it requires the bandwidth of just 64 kbps. Okay, as a computer network person, you should know why this 64 kilobits per second. Okay, so 8 kilohertz frequency. So when we transmit, when we use ADC, analog to digital converter, we have to take samples. How many samples? 8K samples. That is 8,000 samples to be taken per second. Okay, so per second, in every second 8,000 samples to be taken. So normally sample size for normal audio communication, the sample size can be 8-bit. One sample can be 8-bit. Okay, but if you are using Dolphy or any high audio quality data, then the sample size, one sample can be of 64 bits, or it may be sometime it may be 128 bits also. But for simple telecommunication, audio communication, 8 bits enough to represent the sample. So totally how many sample to be taken? 8K sample, 8,000 sample. Okay, so 8 bit per sample. One sample size is 8 bit, but I have to take 8,000 sample in each and every second. So what is my bandwidth requirement? This is nothing but 8 into 8, 64,000. Okay, 64,000 means 64K bits in every second. Okay, 64K bits, that is 64,000 bits in every second. Okay, that's why telecommunication system requires just a 64 kilobits per second bandwidth. Okay, but the 64 kilobits per second bandwidth is not a single cable. Okay, normally when you take a telecommunication system in the street, thousands of homes connected with the nearest trunk office. Okay, nearest toll office. In every house, okay, the telephone is connected with a splitter with the help of wired transmission medium, because it's a landline telephone. Okay, wired transmission medium. I think some of you might have seen that wire is just a low bandwidth wire twisted pair. Okay, so simple twisted pair. I think you might have seen the cable will be like this, insulated copper wire, and it will be twisted like this. Okay, so this twisted pair connects your telephone with the splitter. Okay, located in your home, and this splitter connects your network or telephone network with the nearest trunk office, nearest toll office. Again I'm repeating, trunk toll office. Okay, so all the communication from the entire state passes through this. Okay, so this will be, okay, so normally this link, okay, this link will be the high capacity link. Okay, but this is normally coaxial cable. Okay, coaxial cable, copper core. Okay, so now here existing telephone infrastructure is used for internet. Okay, that is known as DSL type. Existing telecommunication infrastructure is used for internet in most of the developing country. Okay, that is known as digital subscriber link. okay, or digital subscriber line. What is that digital subscriber line? So I have the computer to be connected with a splitter, okay, but the telephone normally carries analog signal, okay, analog signal. It carries a continuous signal, but a computer accepts only digital data. It requires digital data, digital signal to be received and transmitted, okay. So now whenever you use a DSL kind of thing, this line also carries analog signal, okay. So we need analog to digital converter, okay, a modem, okay. So here we have the DSL modem means modulator and demodulator. Modulation means analog to digital conversion, demodulation means digital to analog conversion, okay. Both are required because when the computer transmits the data, okay, the DSL modem accept analog signal and produces accept digital signal, produces analog signal, okay, and it passes through the splitter, and then the signal travels in this coaxial cable. Whenever there is an incoming data, the splitter transmit the analog signal to DSL modem, but digital computer won't accept the digital analog data, so the DSL modem convert analog into digital. Okay, so we need a modem here for modulation and demodulation. Okay, what is the task of the splitter? Splitter is a hardware. Whenever it gets the data from this coaxial link, it just split the data. What do you mean by splitting? If the data is for telephone, okay, then the data will be transmitted to this. Okay, if the data is for computer, it will be transmitted to this. How does it know? Based on packet switching and circuit switching. Okay, so if the data is something related to the telephone communication, data will be transmitted in this end, and if it is something related to the digital computer, if it is something related to the internet, then it will be transmitted to this link. That is the purpose of the splitter. Okay, but it transmit only analog say data only, okay, analog to telephone as well as analog to DSL modem. DSL modem will convert analog into digital. Okay, so this is what the infrastructure, this is what the internet access which are widely used in the olden days of internet, okay, because already established in 1980s or 1990s, telecommunication played a vital role, okay. Telecommunication infrastructure was very good, so that what we did, we make use of the telecommunication infrastructure for internet access, okay. Now if you consider here trunk office, if you take a street, thousands of houses might be available, thousands of houses, okay. All the 1,000 houses input or data passes through this device, okay. This device is known as a multiplexer, DLS multiplexer, that is digital subscriber link access multiplexer, okay. What is the task of this multiplexer? The multiplexer, whenever it gets the data, because the data is not from the single user, it from the thousands of houses, okay. All the data from all these home are multiplexed together, okay, and then transmitted. So the DSL AM is a multiplexer. It multiplexes more than one communication onto the single channel, single outlink channel. Okay, so here multiplexing kind of a multiplexing technique we'll discuss later, but we have three different types of multiplexing: frequency division multiplexing, time division multiplexing, and statistical time division multiplexing. But DSL AM is compatible with the frequency division multiplexing. Okay, so after that, if the data is for internet, okay, then it will be transmitted to the internet service provider. Actually here existing telephone communication, the telephone company itself act as a ISP, okay. So for example, if you want to access internet through DSL, definitely you have to trust on BSNL, okay. So internet service provider is also same telecommunication company, same company, okay, because we are getting both internet as well as telephone access from the same service provider, okay. So if the data is for telecommunication, then it will passes the data to the telephone network, and if the data is something related to the internet, it will pass the data to the ISP. Here we have routers, here we have switches. Okay, so this kind of architecture is known as digital subscriber link. But here you have to think an important point related to the internet, because if you're using telecommunication, I said already, only 64 kilobits per second bandwidth is enough. Okay, but if you're using internet, okay, internet is known as best effort network. I think you might have seen this word, best effort. Okay, so best effort network means if the bandwidth is available, then the user can enjoy the higher bandwidth. Okay, if the bandwidth is low, definitely there is a possibility of packet loss and all those things. So that's why in the nighttime pack is different, daytime pack is different. Whenever you access the internet, if you're accessing the internet in the peak time, definitely there is a possibility of delay. Okay, even you cannot access kilobits of data in the peak time. Okay, if you're accessing the internet in the night time or the time in which or the low bandwidth time, then you can enjoy the highest transmission rate, okay, highest data rate. Okay, so that's known as best effort network. There is no guarantee of a minimum bandwidth for each and every user. You cannot say that each and every user will get the bandwidth of 1 Mbps always, 1 Gbps always, or even 1 kbps always. You cannot ensure that. Okay, if number of users are high, then the bandwidth availability will be low. If number of users are low, bandwidth availability is high. That term is known as best effort. Okay, try to give the best effort. Okay, but in telephone communication, ongoing data as well as incoming data in out both requires only 4 kilohertz frequency. So 64 kilobits per second outlink and 64 kilobits per second inlink frequency is enough. Inlink bandwidth is enough. 4 kilohertz outlink frequency is enough. Okay, so 4 kilohertz frequency band is enough for transmitting audio and video signal. But if you take internet, normally if you access the internet, you can, I think you might be observe this. The incoming packets, okay, number of incoming packets are somewhat very high as compared to outgoing packet as a normal user. But if the system is a server, or if the connecting node is a content provider, Google or Amazon, then the outgoing packets will be very high. Okay, so if you take normal residential access, these computers are used by a normal user. Okay, not content provider, it's just a user. Okay, so if you take a user perspective, uplink data rate is something very less as compared to downlink data rate. Okay, so it provides asymmetric access. What is asymmetric access? For uplink different transmission rate, see here, for uplink transmission rate is typically it allows 1 Mbps data per second. Okay, but downlink, you may download the entire video file, you can download the entire audio file. So downlink frequency normally for internet access, downlink transmission rate should be high as compared to uplink transmission rate. Uplink means what you are transmitting out of the pipe. Okay, just a request. If you're accessing the internet, the uplink requires to transmit only request, HTTP request. Just you are typing www.sastra.edu. That is a thing you are sending. But what you are getting, the entire page with the images, content, everything. Okay, so downlink frequency is high as compared to uplink frequency. So this DSL allows maximum of 10 megabits per second maximum. Okay, 10 megabits per second downlink frequency and the minimum of with a maximum of 1 megabits per second uplink frequency. Okay, so this is what the traditional way of connecting a network internet using residential access. Okay, if you have landline telephone, then you can contact the landline telephone service provider. The landline telephone service provider itself is an internet service provider. Then you can get the infrastructure like this. You can make use of the existing telecommunication infrastructure. Got it? Any doubt?
No, ma'am.
Okay, so let's get into another type of residential internet access. Okay, second type of residential internet access is also reusability. Okay, so another network which are already established network is known as cable TV network. Okay, cable TV network, already established network, is actually a cable TV network. Okay, so cable television, cable TV network is already available. Here, what we are going to do here is we are going to make use of the existing cable TV network for internet access. Okay, but in India, this usage is something less. But in other developing country, most of the developed country provides internet access through cable TV. But in India, this aspect is something less. We use only DSL type internet access. Okay. In the cable TV type network, already existing network is a broadcast type network. This is actually coaxial cable. Okay, this cable is a coaxial cable. See, I said a bandwidth as well as a shared or dedicated transmission link. Okay, if you take DSL type, this is a dedicated transmission link. This is a dedicated till this dedicated transmission link. But after that, this is a shared link. This cable to be shared by n number of users. Similarly, here if you take this, okay, so in this particular channel, this channel to be shared by a number of users. Okay, all the users in the same state. In DSL support a maximum of 1000 users. Cable TV supports maximum of 5000, sorry, maximum of 10,000. 5000 to 10,000 users can be accommodated in the cable TV network because it is not based on twisted path. This is based on coaxial cable. Okay, broadband coaxial cable. Broadband coaxial cable. Okay, so now in this particular case, all the houses are connected already. All the house televisions are connected with the cable TV. Okay, so similarly we have a computer. The computer can be connected with a modem. Okay, this modem is also known as cable TV modem. It provides the same, it performs same thing because cable TV is also receives and sends analog signal. Analog to digital communication, digital to analog communication is the responsibility of this cable modem. Okay, and each and every individual house is having a splitter. Whenever it gets the data, if the data is pertaining to the television, then it will be transmitted to this. If the data is for internet, it will be transmitted to this. Okay, so this perspective is something similar to the cable thing. Okay, but as I said earlier, here all the users data to be multiplexed. This is known as multiplexer. This is cable TV multiplexer. It multiplexes all the input, all the communication, and then transmits the data. If the data is for if the data is for internet access, then it will be transmitted to the ISP. Okay, but it's in the multiplexer point of view, one change is that if you take DSL, the multiplexer connected with the telecommunication networks also because it allows inward and outward transmission. Telecommunication allows telecommunication sends and receives audio signal, but cable TV it won't send the data. TV it won't send the data. It will simply receives the broadcasting data only. Okay, so when it gets the data is transmitted to the television. That's it. Okay, from the television there is no outgoing data. But this is not true with the DSL. In DSL, we have uplink as well as downlink. But television point of view, the device receives only data. It won't send the data back. But now we have smart TV. But that connectivity is something different. Okay, that digital computer perspective or digital computer properties are available with the television. Don't confuse with the smart TV. But traditional way, the television it won't send back the data. It will simply accept the data. Okay, so data to be broadcasted to this television. If the data is for internet, it will be given to the again here the service provider is a cable TV service provider. Same service provider to be used here. If you want to use the cable TV infrastructure for internet access, then the cable TV service provider to be used here. Okay, so this is nothing but multiplexer, cable TV multiplexer. Here the multiplexer responsibility is multiplexing all the traffic from all the incoming traffic, outgoing traffic to the computers, digital computer, not to the television. Okay, and here in cable TV network perspective, the problem here is this channel is a shared channel. Okay, this is shared by thousands of users at the same time. Okay, so if it is shared by thousands of users, I have a single cable. That cable to be shared by thousands of users means at a time more than one user cannot transmit the data. At a time more than one user can receive the data, but at a time more than one user cannot transmit the data. Okay, so we have to include one protocol called the MAC protocol. That is a part of cable TV access. MAC stands for medium access control. We'll talk about more later. Medium access control. In some book it is also medium access control. Some book it is also referred as multiple access control. Both remains meaning remains same, multiple access control or medium access control. We have various protocol for MAC that is implemented as a part of this channel, so that each and every user can take a turn to transmit the data. Otherwise, may allocate the frequency for some period of time. Different schemes are available. Based on the scheme, the MAC protocol runs on this to access the shared channel by more than one user. Okay. Yes, please.
At the entry point of internet for each house, will there be any which controls the speed of internet, which is how.
Good, very good. Is there any speed control or distribution control? I think you are talking
Yes, ma'am.
about. There is no. That's
Some
what.
may take 4
Yes,
Mbps, some may take.
yes, yes. I'll tell you. That is what we have two different type of network. One is known as quality of service network. Another one is known as a best effort network. In the quality of service network, for example, in the internet access, I have four nodes. Okay, and one node may be the server, the other node may be the workstation. Okay, so whenever you get the internet access, the server may need to transmit the data much higher rate. The remaining workstation computer need to transmit and receive the data with the lower rate. If you want to design such kind of thing, then you have to use QoS. Okay, reservation protocol is available, quality of service network to be used. Okay, that is available, not with residential access. Okay, but if you want to enforce or if you want to use QoS type network, we have different network architecture is available, that is known as ATM. Okay, why I am talking about ATM means asynchronous transfer mode network is built on top of existing telecommunication network. Okay, in the existing telecommunication network, we can allocate a different bandwidth to each and every user. One user, for example, one user is pay more or it may require some higher bandwidth. So we can give higher bandwidth. Higher bandwidth can be reserved for that user alone. Okay, so those things are available only in the specialized network, high speed network, ATM network. That is not available for internet. There is no difference in terms of user, in terms of customer in internet. Okay, in an internet point of view, it is not possible to allocate different bandwidth for different user. See, for example, nowadays you are having a different network pack. Some of the person may have 1 GB per day, 10 GB per day, or terabits per day. Okay, but whatever may be the subscription, the internet service remains same. But some of the persons are having high speed access, some of the persons are having low speed access. That is not based on the internet service, that is based on the device you are using. Okay, so if you are using for example, I will tell you in terms of Geo. If you are connecting your internet by using mobile data or mobile phone, your internet access might be different. If you are using modem, Wi-Fi modem, Geo modem, okay, then you can access the internet in much higher speed. So that is not by the ISP, that is not the policy of ISP, that is based on the devices what you are having. But here in the general architecture, there is no allocation. There is no separate allocation for internet allocation or bandwidth allocation for each and every user. There is no separate allocation. So based on the device perspective, some of the user may acquire higher bandwidth, some of the user may acquire lower bandwidth. It depends upon the receiving capacity of the device. Okay, but nowadays we have very high speed internet access, but you can enjoy the high speed internet access only if you have the Wi-Fi or sorry, modem or fiber connectivity in the residential part. But in this perspective, there is no distribution of internet bandwidth to each and every user. All the users are allocated. All the users are using the same infrastructure. Okay, so whenever data is transmitted, some of the user may enjoy the higher higher data rate. Some of the user may have a lesser data rate. Okay, that is not as best effort network. But that quality of service network, guaranteed quality of service network, is not available with the DSL type or cable TV type. Okay, that is available with ATM. We'll discuss later in the class. Okay, so these two are common way of connecting. So this is a broader picture of this cable TV. Now here we have the component called a CMTS, that is cable modem termination point. Okay, so this will terminate the cable modem. See here, there is no link to the cable television because no outlink data. Okay, so that only one link to the internet service provider. Whenever it gets the data, and transmits the data to the ISP. No other splitting here. This is also asymmetric type access. It provides asymmetric type access. For uplink is different, downlink frequency is different. Uplink and downlink frequency is different, but much higher rate. Okay, so because till this we are using broadband coaxial cable. So broadband coaxial cable capable of transmitting the data in terms of 100 Mbps. Okay, so 330 Mbps minimum downstream frequency, downstream transmission rate, and 2 Mbps upstream transmission rate. Downstream transmission rate is much high. Okay, why? Television also requires downstream data. Okay, but this is not true with DSL. Okay, so television also requires all the channel to be distributed to all the homes. Okay, so downlink frequency is 300 megabits per second. Combined downlink frequency for television as well as computer. Okay, television as well as digital device, and 2 Mbps uplink frequency. Okay, and normally this is also known as, in some books we can also refer the component called HFC, that is hybrid fiber coax. Hybrid fiber coax. Okay, so this is one of the trending technique. Okay, in communication point of view, thing is that this each and every television connected with the nearest cable TV link through coaxial cable. This coaxial cable might be replaced by fiber cable. Okay, fiber cable is somewhat very high speed, because fiber works on the principle of light. Okay, it transmits the data at a higher rate in terms of the speed of light. Okay, because fiber cable working principle is completely different. Okay, we'll discuss. Coaxial cable, the copper is used to transmit and receive the data, but in fiber cable the light pulses are transmitted through the glass. Okay, so the transmission rate is somewhat high with the fiber cable. So the television and the entire home connected with the nearest nearest office through cable, and these streetwise cable to be connected with the external component through fiber cable. So the combination of fiber and coaxial might be used for increasing the bandwidth of cable TV network. Okay, that is I have not shown this, but that is available in the real world. That is hybrid fiber coax. Okay, this is also available in India. Hybrid fiber coaxial cable for high speed internet access, high speed residential internet access. Okay, and I said already, this is a shared access, not like dedicated access to the central office. Okay, in DSL type, each and every home is connected directly with a tour office, but here we have common transmission medium that connects thousands of houses. So shared access, we need MAC protocol to resolve the problem of sharing the data. Okay, so these are three different way to access internet through residential connectivity. Okay, next go ahead with the institutional access. Okay, in the institution perspective, there are two options are available. One is wired network or wired connectivity or wireless connectivity. Okay, so wireless connectivity, but here I have one question to ask you. Wireless is one terminology, one common terminology. Okay, mobile is another common terminology. Okay, what about these two? Is it same or different? Wireless, mobile. All the wireless or mobile device, all the wireless communications are mobile communication, or all the mobile communications are wireless communication. Can I say like this? Is it same? Can you find out the difference between wireless and mobile? Wireless communication, mobile communication. Can you say all the mobile communications are wireless? Yes or no?
No, ma'am.
No, wireless is different, mobile communication is different. Let me take this example itself, okay, or even in the institution. If you take a Wi-Fi access point, you see here, we have access point, Wi-Fi access point. Okay, what I have shown is I'm sorry, I have shown what I am showing is a home network alone. Okay, so here in the home network we have access point, Wi-Fi access point. Okay, so this actually this is widely used connectivity in today's network, because in today I said, I repeated several times, IoT is just growing exponentially. Okay, So we have access point here. Okay, so the minimum capacity of this access point is connected with a 554 kbps channel. Okay, so we have so many devices in the home. In addition to desktop computer, we have laptop computer, and we have mobile phone and any other IoT devices, IoT enabled devices, oven, fridge, fan, and all those things. Okay, all those devices need not be connected through wired. Okay, so all those devices are connected through radio waves, wireless communication, Bluetooth or Zigbee radio waves. Okay, Bluetooth or Zigbee protocols. Okay, so it connects with the access point. Okay, so this access point, the access point and these devices are connected through air. Okay, but this access point is connected with the external router through cable. Okay, this is fiber. Okay, so that's why it is known as Wi-Fi, wireless fiber Wi-Fi. Okay, or sometimes it is also known as wireless fidelity. Okay, so we have the fiber channel connects this access point to the router. Okay, so this router connects with a splitter. Okay, modem. Okay, cable TV modem, and this modem is connected with the outside office. Okay, so this type of network is one of the latest one. This is known as FTTH, fiber to the home. Fiber, okay, FTTH, fiber to the home. Okay, FTTH. So directly the fiber cable is available. So through this the modem connects with the router, and this router connects with the access point. This access point connect all the devices in the coverage area, same coverage area. Okay, so this device, this access point and all the devices should be in the same coverage area, and this access point to be connected with the cable by using wired fiber cable. Okay, so this is one of the latest way of accessing the residential internet access, so widely used FTTH. Here I am using some security related component, that is firewall. Okay, because whenever you get the data, there is a possibility of malware, spyware, injection, and all those things. To avoid that, we can install firewall. This router is known as edge router. Okay, so we can set up the firewall here. This is a router, so I am using the term router, and it also equipped with a terminology called, may not be added with a terminology called network address translation. Network address translations are required if you are using IPv4 address. Otherwise, if each and every device is assigned with IPv6 address, this is not required. This is used to convert private IP address to public IP address, public IP address to private IP address. Okay, so all the devices are connected by using wireless medium. Okay, but I asked a question about wireless or mobile. What is the difference between wireless or mobile communication? So here, is it completely wireless? Can you tell me let me take this laptop A. Okay, so laptop A connected with the access point through wireless. Is it right?
Yes, ma'am.
Okay, but will it allows mobility? Will it allow mobility? What if it be mobility?
Movement.
Okay, if you take the laptop from your home to the neighbor home, okay, still is it possible to continue your internet access?
No, ma'am. No, ma'am. No.
So mobility means here it allows wireless, but it won't allow mobility. Okay, but you take your cellular network, your telephone, okay, wherever 4G or 5G connectivity, wherever you go, I think one advertisement, Vodafone, wherever you go, our network follows. Okay, so similarly, wherever you go, you can access the internet. That type of you can not only accessing the internet. Okay, see, mobility means you are moving from one location to another location. The devices will move from one place to another place. During that movement, can capable of continuing the communication. That is known as mobility. Okay, so mobile communication is different. Mobile doesn't mean mobile device, even laptop or any other device. Okay, so you can access, if you can able to access the internet or network during mobility, then that communication is known as mobile communication. All the mobile communication need not be wireless. Okay, all the wireless communication need not be the mobile communication. So in this case, it allows wireless communication, but it won't provide mobile communication. Best example for mobile communication is the internet access, 4G or 5G cellular network. Okay, I'll talk that later because 4G, 5G is one common way of connecting with the internet. I'll come to the end, okay? So that is the thing. So three different type of home access. What are those? DSL kind and CTV kind. DSL or cable TV, what we are doing? We are using existing infrastructure, existing telephone infrastructure and existing cable TV infrastructure. But we have dedicated internet infrastructure by means of FTTH, fiber to the home. Okay, we can have router, we can purchase the router, and the router can be connected with the modem. All these are very cheap in price, so that you can connect all the devices with the modem. Okay, I think you might be using Geo modem or something like that, so you may know, you can easily feel this kind of network. Okay, let's get into the enterprise network. Okay, organization network or enterprise network. In enterprise point of view, we have two different type of network. One is wired network, another one is known as wireless network. Okay, one wired network means what is the purpose of internet access in institution? In institution perspective, if you take any software company or any organization or any university or any institution, there may be computers, thousands of computers or hundreds of computers. Okay, all the computers might have its own task. Okay, if you take any organization, some payroll is running on one computer and some processing may going on another computer. So all those are offline. Okay, all the computers are having some offline work. Okay, but sometime then and there they need to access the internet. Okay, so all the computers to be connected with a common cable. Okay, that common cable to be connected with the internet access. Okay, so all the user cannot access the internet at the same time. Okay, that won't happen at all. If you have 100 computers, if you take Sastra University, we have two internet connectivity, one from BSNL, another one from Reliance. Okay, but we are not using all the internet access at the same time. Only some of the user may use the internet, some of the user may be engaged with some offline work. Okay, so internet access in the organization perspective, different types are available, but one common type is the Ethernet access. Ethernet means IEEE 802.3 local area network. Okay, let me write this. I'll write down the standard, but we'll talk about the standard later. More about the standard IEEE 802.3. Okay, Ethernet access, also known as wired LAN network. Wired LAN network. Okay, so this is a modern connectivity of wired LAN network, but previously the structure is something different. So in the modern Ethernet structure, what we are having here is a switch. Okay, this is known as the Ethernet switch. The Ethernet switch is connected with n number of computers. So here this computer and this one and these four computers are connected with the four different ports of the switch. Okay, and see, some for time being, just omit this. Okay, just don't worry about this. This structure is something like this. I have the switch. Okay, the switch is connected with n number of computers. Okay, so this is a way of connecting the local area. This is a way of creating the local area network. Local area network. Okay, so the computers inside the same building, connected by using the single twisted pair cable. Each and every computer to be connected with a switch by using twisted pair cable. Okay, I think all the computers, all the laptop computers as well as PC and workstation computers are having Ethernet port. Okay, you might be seeing the Ethernet port through which you can connect with a switch. Okay, this switch is connected with the external world. Okay, as far as this part is concerned, this is completely a local area network. What is the purpose of local area network? This computer can send and receive the data to this computer. This computer can send and receive the data to this computer. One of the computer may be the printer. Okay, so see, this one might be replaced by a printer. So this device might be replaced by the printer. So the printer can be shared by all the computers. All the computer can send the information for printing to this printer. Okay, so resource sharing is the main requirement of local area network. So inside the same building or same room, the computers are connected with a switch. Okay, till this private network. The switch is connected with a router. Once it is connected with the router, this router, then it can send and receive the data to the public network. Public network means internet. Okay, this router connected with the public network, internet service provider. Okay, in Shastra point of view, we have connected with the BSNL as well as Reliance. Okay, and this part is a separate another local area network. Okay, normally if you take any organization, startup or any organization, definitely we have two server. One is a mail server, another one is a web server. Okay, web server to send and receive web request, and we have mail server. Okay, in Shastra we have a www.shastra.edu is a web server, mail.shastra.edu is a mail server. Okay, each server is having a separate IP address that is connected separately with a switch. Why? The request, see this link is somewhat dark in size. Okay, that means the bandwidth requirement of this link is high because the server will be disturbed very frequently. It will receive the request in terms of thousands of requests per second. Okay, so this bandwidth, this cable might be a fiber cable. Okay, but this cable, the twisted pair cable. Okay, the bandwidth requirement of this is simple, is less. Okay, now this again one local area network. This is connected with a router. Similarly, if you take organizational network, constructing the local area network by using twisted pair cable is something costly. Okay, if you have thousands of computers, again there is a possibility of to put a high huge little bit higher amount. Okay, one cheaper way of creating a local area network is by means of wireless LAN network. Okay, Wi-Fi IEEE 802.11. Okay, so here we have access point that access inside the same building. In Shastra, in every room we have an access point. Okay, so through that access point, all the computers inside the room can access the internet. Okay, so these computers, these laptop devices, laptop connected with the access point, and this access point connected with the router, and this switch connected with the router. Okay, close this. Okay, so this switch connected with the router. So this type of architecture is known as enterprise network Ethernet architecture. Typically, it's a typical architecture for most of the universities, institutions, and organizations. By using this, we can achieve 10 Gbps transmission rate starting from 10 Mbps. Why this 10 Mbps to 1 Mbps to 10 Gbps? Based on the cable you are choosing. Okay, if you are using coaxial cable, then it will be in terms of Mbps. If you are using fiber cable for connecting all the routers and switches, we can achieve Gbps speed. Okay, so transmission rates are in terms of Gbps. It's a typical structure of any organizational internet access. Okay, let me complete with another type of organizational internet access. As I said earlier, we have wireless LAN architectures completely 802.11. We have devices. The devices are connected with access point. The access point is connected with a local area network. This is similar to our FTTH, fiber to the home. Okay, and for worldwide access, we have wide area access network. In the wide area access network, we can contact the cellular company, and it provides internet access. The range is in terms of 1 Mbps to 10 Mbps internet accessibility is possible. But based on 2018 data, we have 3G, 4G cellular communication, and nowadays we have communication 5G. 5G not in India, not yet available in India, but we are going from 4G to 5G and 6G. All these things are available. Okay, we have a satellites through which the devices can communicate, can send and receive the data, and the location of antennas, satellites, and all those things are the infrastructures constructed by the cellular company. Okay, so that is a way of accessing the internet in the wider range. Okay, I'll stop here. So for wireless connectivity, for personal area residential access, we have three options: DSL, cable TV, and fiber to the home. For institutional access, we can connect your Ethernet LAN network with a public network, and wireless LAN network with a public network. So IEEE 802.3 is one standard. IEEE 802.11 is another standard for LAN to internet connectivity. For wide area access, wireless access, we can get the connectivity from the a telecommunication service provider, cellular network. So from the cellular network, you can achieve the speed of 1 to 10 Mbps speed with different generations. That is actually dominating today's world. We'll talk more about the cellular network in the later classes. Okay. So these are the different way of accessing the internet. I'll stop here. If you have any doubt, you can ask me now.